Hello, everyone. I'm going to go ahead and get started. Thank you for joining me today for this session on creating your own blockchain network. Before I jump in, I do want to remind everyone and show everyone rather our code of conduct. You can take a moment to read through it. As you can see, it's just asking everyone to be kind and friendly and professional to one another. So please just follow that in this session and any other future Reactor session. We could all use more kindness in the world. Here is the agenda that I'm going to be following roughly for the next hour. I'm gonna just have a little bit of an overview about what to expect. I am gonna be kind of jumping in to talk about using smart contracts to build blockchain applications, using Solidity as the programming language to write those, highlighting various tools for development and showing off a number of those. I will focus then on writing a smart contract, but really want to spend even more time kind of testing and interacting and having time to observe and then look at the transactions and events that are happening across the network. And then I will save some dedicated time for Q&A at the end of this workshop, but please also feel free to ask questions throughout. I'm doing my best to keep an eye on the Q&A window, so love to hear just any thoughts, any questions, anything that you want to share. Please feel free to just go ahead and throw it in the Q&A window. My name is Megan Lewis, and I'm a senior program manager here at Microsoft. My focus is around creating and delivering learning experiences for our Microsoft reactors worldwide. I do focus on emerging technology in particular, which is pretty broad, but it's really cool for me in this role to have the opportunity to kind of define what that is and what technologies that I want to focus on and learn about and kind of create content for. So I am currently focused on blockchain. I've done a number of workshops and streams in the past. Maybe you've seen some of those. I can share resources afterwards to point you to some of those as well. I'm also now focusing on Rust and Go as kind of this emerging language series. I do have a passion for teaching lifelong learners. Even that definition is very broad, so students, developers, anyone who I think is like me and has a passion to continue to learn new and interesting technology. And I live in the San Francisco Bay Area. I've been here for about the past decade. I'm a California native, and I live here with my husband and our 2 dogs. So I am going to be going over this learning module on our Microsoft Learn platform. So I want to go ahead and share out the link to this. I can also throw it in the chat. It's aka.ms/contracts-with-solidity-8. So this module is all about writing Ethereum smart contracts by using Solidity. So I'm going to be following through that. I recommend that you kind of take note of the link and feel free to follow along and complete the module in your own time later, but you don't have to follow that so closely now. So let me go ahead and throw the link in the chat for that. There we go, and hopefully you've had the time to bring that up in the meantime and reference later. So what you will need to know to follow along is some fundamental knowledge about blockchain itself. I'm not necessarily starting with the basics or kind of the introduction to blockchain. I'm assuming that you know some of that. Similarly, I am going to be building on the Ethereum platform, so I am going to assume you're familiar with how Ethereum works as well. The next few points are just kind of knowledge about how to download some programs, how to use the command line. Ideally, you already do have Visual Studio Code installed. That's what I'm going to be primarily using today, Visual Studio Code with the blockchain development kit for Ethereum, but there are alternatives and I'll go ahead and share that. So if you want to follow along, and I highly recommend that you do, you're going to need to choose one of the options that I'll share in just a moment. So how to create your own blockchain. These are just a few of, I think, the core steps that you need in order to get your own blockchain network off the ground. First, you need to identify a use case. So there are really a vast amount of use cases. I'm not really going to get into what's a good use case and what's not, unless folks have questions about this. Please feel free to ask. But generally, you want to consider who the participants are going to be, what's the performance of the network, how is it going to work, what's kind of the logic and code behind it. But the idea is you're going to start this process of creating your network when you have some idea in mind about what use case it is and how you want to build an application or indoor business around that. So then the solution will need to be coded using distributed ledger technology, DLT. This is typically going to happen through the use of smart contracts, which I'll talk about next. The key idea here is that you're using logic to define the rules of how your system works and who participates in the network. You also need to decide how people will be able to join your network and whether it's public or private. So public, anyone can join. Private, it's going to be a little bit more permissioned. And your custom solution will then have its own ledger to capture history of all action, transactions, events on that network from the beginning of time. Around the same time of this, you're also going to want to think about what platform you're targeting. It is going to be really common to build off of the Ethereum platform, which we're going to do today, because that is the world's programmable blockchain. That's really where we've seen pretty much all, let's say most of these applications and businesses really being built off of that, and kind of the options that Ethereum has provided for developers to actually create their own blockchain networks. And then you can use technology to test your solution on a local network. I recommend starting there. That's really what we're going to focus on today. Of course, once you get past local, there is going to be test nets and other kind of networks that as you work towards production, you want to have time kind of using those networks and kind of getting the feel for them there if it is a public blockchain. Then finally, kind of once you're happy with how things are working, you are going to want to think about, how the UI is going to look. So I think at this point, you're going to want to create a D app and kind of think about how the admin side of your whole app is going to work and look. All right, so let's talk a little bit about what a smart contract is. A smart contract is stored inside of a blockchain. It extends the blockchain from data to code, and it usually represents an agreement between parties, between at least two parties. This agreement is coded, and when an action happens, the code runs and provides a response. So all of the terms and conditions of the contract are programmatically defined. A definition, again, specifies the rules, requirements, and rewards for the participants and the blockchain. It also specifies how digital assets are going to be transferred between these parties. So whatever the digital asset is. In the example today, we're going to be talking about a shipping company for whatever fictitious products that we think of. So it can be any kind of sellable items, very broad here, but you have to kind of think about how those digital assets are going to be transferred and code that into your smart contract definition. Smart contracts run on their own. They send events with trigger state transitions and call functions. They are perfect for blockchain technology because they allow people who don't know one another to do business together in a secure way that doesn't require the use of a middleman. As I mentioned before, smart contracts are most commonly used with Ethereum, the world's programmable blockchain, and the language to write contracts is Solidity. So Solidity is kind of the official language of Ethereum. There are other options out there, but I'll talk about some of the benefits of Solidity as we kind of get into the example and why you might want to use that in particular as opposed to some other languages. So let's go ahead and talk a little bit more about Solidity, actually. Or no, not yet. Okay, so smart contracts have the key benefits and advantages. They are transparent. Blockchain users can read smart contracts and can access them by using APIs. They are immutable, so smart contract execution creates logs that cannot be changed all the way from the beginning of time. You can see that, so that's another thing that adds to the transparency. And they are distributed, so the output of the contract is validated and verified by other nodes and participants on the network. And now let's talk a little bit about Solidity. So Solidity, just a Some key points about it: it is a high-level object-oriented language for writing smart contracts. It is based off of other languages like C++, Python, and JavaScript. So if you are familiar with any of those languages, looking at Solidity, I think it might be a little bit more familiar to you in that case. It is statically typed, which means that type checking happens at compile time, and that also means that you need to specify the type of each variable. It supports inheritance, so this means that functions, variables, and other properties in one contract can be used in another. It also supports complex user-defined types like structs and enums, which are going to allow you to group related types of data together. It is an open source programming language. I think, these days most programming languages are actually open source, but it's just nice because this is a language that is continuing to grow and support and kind of evolve over time. And I did just go ahead and throw the link to the Solidity website, but if you Bing or Google it, you can get there and kind of learn more about that as well. I'm not really going to show any more or talk anymore. I think as we get to the demo, we'll get hands-on with Solidity and explore that even deeper. All right, so the tools for development that I am going to be using and just that are commonly used for blockchain development are Visual Studio Code as the IDE. The alternative there is Remix. Remix IDE is a really nice browser-based IDE where you can build Ethereum contracts in Solidity. It's a great way to explore contracts and kind of get more familiar with how it is building out blockchain applications. So I highly recommend this just because you can go to Remix and get started right away. With Visual Studio Code, I'm going to be using the blockchain development kit for Ethereum extension. I'll show that off a little bit. And then as far as frameworks go, the most popular ones are Truffle Suite and OpenZeppelin. So with Truffle Suite, it provides a really nice set of tools that make it really easy to develop blockchain applications with. So there are a few different tools: Truffle, Ganache, and Drizzle. So in this workshop, I'm going to be focusing on Truffle as kind of the development framework and Ganache, the blockchain server. And that is about it. I won't focus on Drizzle. Drizzle is what you need to actually build applications. So I'm going to have some future sessions about that, but we'll ignore that for the purposes of today. I also want to call out OpenZeppelin. I'm not going to be using this today, but it's been one of my favorite tools to explore development with recently. OpenZeppelin provides a couple different products, one of which is the contracts library, and the contracts library is a set of well-defined, tested, secure contracts that you can easily integrate into your own blockchain projects. So this is really nice because it kind of can allow you to spend more time thinking about how to fully build out your application and get your app and your idea into production. So I really like that just because it can help accelerate development and allow you time to focus on some more important things, right? All right, so I'm going to now transition over to the demo. I'm going to be focusing on this shipping status contract. And let me hop over now to my terminal. So what I'm going to start doing in here, actually give me just a moment. Get out of there. And again, feel free to ask any questions if you do have them. I am going to now start to create a new project just from the terminal. I'm going to use Truffle to help me do that, like I had mentioned. So from my projects directory, I'm going to go ahead and make a new directory called shipping. And let's go ahead and cd to shipping. So first, I just want to go ahead and type out the command Truffle and wait for that to run. So I just want to highlight all of the different commands and options that are available with Truffle. As you see, there are quite a few. It's definitely worth exploring all that Truffle has to offer and kind of just going through and exploring these commands. To start with, I'm going to go ahead and initialize a brand new project. So to do that, I can say Truffle init. and it will start to do some things for me, download this box and basically just set up a template of files that I can use to help build out the project. So I will open this up in VS Code so that we can start to take a look and explore there. All right. So now with VS Code open, before I jump right into things, I will call out just once again, I am using the blockchain development extension. So how you would get that is kind of click on this building blocks icon over in the sidebar and just look for blockchain development. And you can find this extension here and just immediately install it. I also didn't point out that I had already pre-installed Truffles. So if you were following along, you would need to make sure to do that. All right, going back to my project now, I am going to just kind of show off what's here for now. So I have just a sample contract, this migrations contract, an initial migration, and the Truffle config. So the Truffle config is really what's going to allow me to specify very specific project and network options. So all of it is commented by default. I am going to want to at least uncomment this portion here. So this is just specifying the development network that I'm going to be using, and that just has some information by default about the host and port that I want to connect to. So this is the blockchain server that I'm going to connect to using Ganache momentarily. Let me go back and actually let's just start writing the contract and showing off a little bit about Solidity and how a typical contract is going to be structured. So I will right click to create a new file, and I will call this shipping.sol. Let me close this other stuff so it's a little bit easier to see here. And I'm going to just go ahead and copy this from the other file. This is the pragma directive, so every contract is just going to need to specify the version of Solidity that you want to actually compile against. The current version of Solidity, if I recall, is 0.7.4, so I just kind of give a range here. It's a pretty broad range. This is helpful for whoever else might be running this contract, even if I put this contract in Remix, and Remix has a bunch of different compilers that I can use, but it just provides a range, so it's kind of the safe bet to use. And I'm going to now define my contract name, which is just going to be shipping. And after that, I am going to define a new enum. So this is one of those user-defined types that I was talking about, and this enum is called shipping status. And the predefined values that I want to give this shipping status enum are pending, shipped, and delivered. And then what I want to do is to save this enum shipping status in a variable named status. So I can now say the name of the enum again, and this is going to be a private variable, which is going to be only available within the context of this particular contract, this shipping contract. Then what I'd like to do is create an event. So the events are really a crucial part to Solidity contracts, where they can log very helpful information to the ledger, just to kind of keep track of the different transactions and things that are happening on the network. So this event I'm going to call log new alert. And that is just going to take in a description. So this is a pretty broad alert. It's just giving me a lot of flexibility that I can pretty much call this alert whenever I want to and provide some kind of descriptive message or description about what's happening at that time. So it's just going to allow me to get a little bit more helpful logging information in my blockchain ledger. And then next, every contract will have a constructor. So this constructor is called at the time of contract creation. It's just going to do whatever I specify that's in the body of the constructor. So what I would like to do here is set the shipping status to pending. So the status is always going to have this default value of pending by default. And then I'm going to start to specify a couple other functions. So functions are another core part of any contract, because you can directly kind of interact with them and test out these contracts to see that they are doing what you expect. So I'm going to have a couple functions. First, I'll write out the ones for shipped and delivered. So these are going to allow me to change the status from pending to shipped to then delivered. So first, let's write out the shipped function. This is going to be a public function as well, so I can use this from within other contracts. Hopefully, I will get to show that off later. All right, so then I can change the status to shipped, and then I can also emit that alert, or I'm sorry, that event. And I can say your package has been shipped. That would be the message that I see when I call this function. Next, I'm going to have a function called delivered, which is going to be very similar to this function above here. Let me scroll down a little bit. And so the status will be updated to delivered. And then I'm going to emit a new log alert again. So your package has arrived. All right, and then I'm going to have two more functions after this. Okay, so I'm going to have a function first that is going to allow me to get the status. So this is just going to allow me to basically call this function from within this particular contract to just know whatever the current status is. So one of the three up here, it's just going to be one of those. So I do want this to be specific just to the context of this contract, and I'll talk a little bit more about why that is in just a moment. This is also going to take in another variable called status, and I'm differentiating this status from the status that I've been using elsewhere with this underscore. It is going to be an internal function, so this internal function is only going to be visible in this contract definition. It is going to be pure, so that means that I can't modify or change the state of what's happening in this contract. Cool. And then that is going to return a string from memory. So what I'm going to do in here is just write a series of if statements to return the appropriate status. So if shipping status dot pending is equal to underscore status, return pending as that status. So we would return that string from memory. And then the next two lines are going to be very similar. So let me just copy those quickly and then I can talk more about it. So next, if the status is equal to shipped, we would want to return shipped. And finally, if that status was equal to delivered, we would want to return delivered. So just going to have those three statuses. Then what I want to do following this is I'm just going to create one more function quickly that is going to be called status, and it's going to call that get status function. So this is going to be a public function. So this I can use externally, whereas the one above, I just want to be able to get the status. I don't want to be able to modify. I don't want to have the possibility to modify anything. Returns another string from memory. And then this is going to say shipping status underscore status is equal to status. And then the last line would return get status. underscore status. So we're just, again, kind of differentiating those two different statuses here, and then going up to be able to get the status. So all this is going to do is just, these two are going to allow me to like know the current status of wherever my shipped item is. So let me check and see if there are any questions. Can I connect to Geth via, for example, using Web3 instead of Coinbase? I'm not sure I completely understand that question. Could you possibly rephrase that instead of Coinbase? I think so, but maybe if you could possibly rephrase that for me, thank you. I only find Ethereum mainnet connections via Coinbase and Fira or wallets already on the market or via testnets. I think that maybe was a little bit of a follow-up from that last question. I only find Ethereum mainnet connections via Coinbase, Infura, or wallets already on the market or via testnets. So I think, yeah, I'm trying to talk myself through it. I think that's maybe a follow-up about can you connect to Geth because maybe you're only seeing other types of networks via Coinbase or via wallets. Want to do it with my own wallet via JSON, for example. Let me think more about that scenario. That I'm not completely sure off the bat. I think that's something to explore. Yeah, because I'm not really sure. I'm not sure what the problem is, but I think the whole question about can you connect to Geth, I think it should be a possibility, but let me look into that. Thanks for the questions. Yeah, and feel free to keep them coming. I will get back to you. All right, so now let's go ahead and keep things moving so that I can have time to get back to these questions and kind of show things off and show actually connecting and deploying to various networks. So I do want to go ahead, and I can use Truffle to do this. I can also use the blockchain development kit, so I can show off both ways actually to do this. So let's go ahead and start with just a Truffle build. And that will just build my contracts. I see that they are compiled successfully. Alternatively, what I can do is right-click on the contract, and I can go ahead and say, build contracts. Let's focus on the shipping contract in particular. I'll build that, and that should build successfully. Then I'll get ready to deploy it. And that looks like it is compiling successfully. So then what I'll want to do is go ahead and create a new migration. And so this is going to be called to deploy contracts.js. This first migration, and all migrations are essentially the exact same, so I can just go ahead and copy this one over to this file. And so instead of deploying a contract called migrations, I'm going to focus on my contract that's called shipping. That is in the shipping variable, and then can also specify the deployer to deploy this shipping contract. So then let me go ahead now and right-click to deploy contracts and see what happens there. So this goes back to the Truffle config file earlier that I was using, and at least the first option that you see is specifying what I'm seeing from development. So that is going to take that information from my local host at port 8545. You'll notice there are other options here. So I can deploy to Azure Blockchain Service if I like. That is really going to be if this is going to be a public network and I want to kind of manage my network there. There's also Infura. So Infura has a number of options there that I can deploy to as well. For now, let's go ahead and focus on the local. All right, and then as I am looking through that deployment output, we'll just focus on this for a second. I see the output of that, and this is basically where I can start to see how my ledger is being built out. So here we are creating the first block through the migration and creation of this contract. So I can see just different metadata here about that. So the block number, the timestamp, the account that was used to deploy. So by default, the Ganache server is giving me 10 accounts that I can work with. So I'm using one of those accounts that has some test ether. And you can see here, it used a slight balance of ether. So based on this gas used, the total cost, and that was decremented from my test account. Similarly, I am deploying the shipping contract and I see that similar information here. I see new blocks being created and other metadata about that. So I think this is where it starts to become really helpful just to see and get a better idea of what is actually happening on your network. So you can get that information here. You can also see it in the, let's go ahead and start that up. You can also see if you go ahead and actually, okay, I do already have Ganache CLI running, but let me restart that just so I can show it again. So that is running at port 8545. I don't remember where I have it running. I'm trying to listen to what is at that port. I thought that was the right command to do that. One second. Okay, there we go. So I'm gonna just try to kill this process. I meant to kill that before, sorry. And let's try to start this again. Let me clear this out. Sorry, it's probably a little bit small. And let's go ahead and start that again. So I'm just gonna start up Ganache CLI. There is also Ganache GUI, which is really nice as well to kind of allow me to see things in a nicer kind of visual manner than what I would see in Ganache CLI, but this is kind of some of the same information here. So I do see the available accounts that I have, so 10 accounts that are available for me to kind of test and interact with, as well as a set of private keys here. I have my mnemonic, which is going to allow me to access that wallet, and just other metadata here. Again, I do see that it is listening on that port. So let's go back now to the other terminal window. And even if I do a truffle deploy here, I should start to see action happening on that server again. So I'm seeing kind of the same information I saw previously, that what I did with the blockchain development kit here, I'm just explicitly telling Truffle to do it. And if I go back to the other terminal window, I can just see that Ganache CLI has started to send some more metadata, so I can get a better idea again about what's happening actually on my blockchain ledger. So I can see kind of the first blocks that are created there. This is contract creation. This contract gets a unique 20-byte address, other transaction address information. And again, I just find this helpful to kind of look through and start to understand what is happening on my network. Is it actually kind of receiving information? Is the ledger capturing information like I expect? Right now, it's just a very simple contract that we have, so I would totally expect it to. This is likely the point where I would want to introduce testing. So I can go ahead and create a new file and just show off a test. And as we test, I want to really think about how I can kind of verify and gain confidence in what my contract is doing. So I would have, sorry, let me go ahead and finish this. .js. So I would have different tests for, let's say, each of the functions. I want to go ahead and test those out. I can also test my events, for example. So let's look at what that is, what that would look like. And notice that this is a JavaScript test. You also do have the ability to test using Solidity. Either one of those are fine. I think with JavaScript, you have the ability to really test your code a little bit at a deeper level. So kind of testing, again, the functions and that information. Whereas I think with Solidity, you're testing, the interactions on the blockchain and specific outcomes from that a little bit more. So let me go ahead and open up and rather just copy over this test quickly, and then we can talk through it. Please feel free to ask more questions or comments. If you have them, throw them in the Q&A window. All right, so this test that I just copied over, again, what it's doing is testing the different functions. So I do have a test to check and test out the pending status. So just checking that the status is initially pending as we would expect it to. We have a test that confirms that the status is shipped. So after it actually calls that shipped function, we assert that the status of shipped is returned. And then lastly, we have a test that checks the outcome of the delivered function after that's called. So let's go ahead and run this first. And to do that, I'm going to open up my terminal and go back to that first terminal window, and we can run truffle test here. Oh, yep, that happens. I did name this something slightly different. So this contract is shipping and not shipping status. Let's try that. Okay, cool. So then what it quickly does is run those 3 tests. And if I go back to my other terminal window where I have my blockchain server running, I should see a whole new set of transactions that happen over here, just to let me know what's happening. And I can kind of even look through these different Ethereum transactions. So on my local network, they're just running a series of these commands. So this is helpful just to get a little bit more insight into what's happening. I think going to switch over now and kind of show off what you can do with Remix. I think Remix provides a really nice way to start to interact with your contract at a different level. So outside of testing, that's definitely one option that you have where you can start to get more confidence into the behavior of what your application is actually doing. There is a feature to do that in the blockchain development kit extension. It just doesn't always work, so I can't confirm that, but this kind of has this like built-in feature to create this DApp for you that would allow you to interact and call the functions, but I don't have a lot of luck with that personally. So let's go over and see it in Remix because that is a pretty sweet tool that allows you to see and kind of do much of the same things, but in a different way. So here is this shipping status contract that I had copied over before. And I can go ahead and first let's just compile this again. And that was probably successful. I should clear this out and leave it open. But yeah, I didn't see any problems, which we would see problems over here if there were. And then let's go ahead and deploy this. All right, so if I look down in the logs, I can see that this creation of the shipping status contract was pending, and then I can see different metadata here. So this is very similar to what the Ganache CLI server was showing me. Maybe not the most helpful information right now. What I do want to get into is this deployed contracts portion over here. So this will actually allow me to interact with the different parts of my contract. So I can have, I can call, oops. I think it's this one. I was looking at an older deployment. Okay, so here I can see that I can call these 2 functions, delivered or shipped. I can also call status. So status by default should be pending, which you see here. I could also call, let's say, the shipped function. So then if I update the status again, it will be shipped. And then similarly, I can see that information down in here. And what I like to see down here, you'll even notice this information is super clear. So I call to shipping status, you know what function is being called. And if I look down in here, I can see, yeah, more information about the call. I was hoping to see the event string shipped. I was looking for that particular string that I had set that said your package has been shipped, because I think that's where you start to get even more rich detail about what's happening on your network and seeing this information. But I do not see that event data yet. So let's see, let's try delivered, see if we see anything different there. And I do see that here. At least I have a little bit more specific logs, but I see a couple different things happening here. I see the accounts that this was called from, so that should correspond to an account up here. So this is the same set, or just similar to what I was seeing with Ganache. I get a set of default accounts. I do notice that it calls that event, and I see that event message here. So that is some information that wasn't as easy to get in the VS Code extension that I really like to see here. All right. There is one more thing that I'd like to show off here. So I've just really showed this example of a standalone contract, right? But as you are thinking about building out more complex applications, you want to think about how, you know, your contracts can kind of work with one another. So if you are used to programming in other languages, let's say like C, Python, JavaScript, for example, you know, you want to have one class that does one thing. So similarly, I have just this contract that's really focusing on shipping. But say, for example, that I want to then interact with another contract, like I want to think about more of like how my let's say my marketplace business is going to work. So I do have this marketplace contract over here that is allowing me to do a little bit more things like buy an item, for example. So let's say that after I buy an item, I want to ship it. So I can start to think about how I can interact and kind of combine these two contracts to, I guess really the idea here is showing off inheritance. That will be the focus of this. So I have this marketplace contract. So if I wanted to use some functionality from that other shipping contract, I can go ahead and import that here. And that contract is called shipping status.solidity. I can close some of these other ones. It's actually just called shipping. All right, and then at the top of the contract where I am specifying other state variables that I want to use, I can also create a new variable for shipping. And I specify a status here. I have other events that are part of this other contract. Let's say that in my constructor, I am specifying the seller, I am setting an item available. After this, I might also want to actually do something with my status or just initialize this variable. So I can say something like status is equal to new shipping status. And then I can feel free to use that, any of the contract functionality from shipping status within the contract of this marketplace. So let's say that after I buy an item here, I have emitted this purchase item event. Then I could say something like, let's say that I want to change the status of the item after that. I can say something like status dat shipped. For example, if I want to then say that, okay, we bought this item and then we shipped it. So let's go ahead and compile that. and then deploy this contract again. I see that the creation of this marketplace was now pending. So then I get a whole new set of deployed contracts up here. So this is saving my information from earlier. I probably should have refreshed that because I have different accounts now. Or actually I don't. I think those look the same, but let's copy them to be sure. So let's say that my buyer is going to be this account, and that my seller is going to be the second account. Top one there, and let's say we're going to buy something for 10 fictional Ether. And then I see that this transaction was pending here, and this is telling me that it's successful. So I should be able to look in this output and see some information here. So I should see this event that was emitted about the item that I purchased. And then I did expect to see some information about the shipping as well. So this should have called that shipped function, which should have admitted your package has been shipped, unless I did something wrong. But this is a really nice way to start to combine contracts and collect that metadata across multiple contracts as I'm interacting with them there. And it is possible that I did something wrong, of course. So, all right. I'm calling the right function. Let me just do a little bit of quick debugging and figure this out. Shipping status, public shipping. I could all call everything shipping instead. Shipping. All right, and now, oh, okay, but that did cause an error, so that's good. No, you want that to be shipping status. That is the name of the enum. Okay, so that would be creating that new status. All right, then I think I was doing everything correctly. So I'm going to try this one more time and see what happens. And this is why I really like Remix. So you'll notice that you do already have these contracts by default. I've also created my own contracts and they just persist here. So anytime I come back to Remix, I have access to them. And it allows me to try things out without having to download any software and to kind of just interact with these things. I get a really nice kind of test network within this to allow me to interact with the contracts. So I did now compile, so let's deploy again. I might even refresh this quickly. I don't like that it keeps the same information in there. I'm wondering if there's some kind of old data here. So let's go back. Notice that if you do refresh the page, it will kind of lose everything again, but I should be able to get it right back if I just open our contract again, compile, deploy. So that's just the deployment information. I promise I am wrapping this up, so I'm going to get to questions. And that's just the deployment. So now I should be able to interact with that contract. And so let's say that I do want to buy something. Now I don't have any of that data persisted. So let's say that this first account will be my seller. The second account will be my buyer. And let's buy something for maybe 100. Okay, and I do see a little bit different information there. So I do at least finally see that second event that's been logged. So you can kind of combine different events being emitted and different logs, so you get all kinds of helpful information in your ledger to let you know what's happening. So I think that's all that I have to show here. Let me go ahead and jump back over to the slides. So I just want to call out what's next and kind of where else you can go to learn more. So if you do want to kind of continue down this path of exploring blockchain development, you can check out the Blockchain Development Learning Path on Microsoft Learn at aka.ms/blockchain development-8. I can throw these links in the chat too. We also have a bunch of other blockchain videos up at aka.ms/reactor-blockchain-videos. I've done a series of streams and workshops. Other folks have had other talks, and they're up there, so you can find kind of a series of videos there. There is going to be another series, and this session next week is dedicated to pretty much questions. So really want to spend some time to explore and dig into very specific, scenarios. I might have some demos to show off next week as well, but that's a little bit more about what to expect. Just generally, I would say, and I always tell you this, I think these sessions are meant to kind of talk about and highlight different things, like different tools that you can use to create your own blockchain networks, different solutions that you can explore. But it's really, important for you to think about what sparked your interest here and what else you want to go learn and explore. This is just another call out for this session next week. So it's November 19th, same time. Feel free to register for that event now. A quick call out to just join our community. I'm thinking y'all are already part of the community if you're here today, but you can go ahead and follow us, our YouTube meetup, follow us on Twitter, sign up for our emails to learn more and kind of stay up to date with events. Of course, we are constantly having events. And this is a call to please take our survey. So it's a quick survey at aka.ms/reactor/survey. We will throw this in the chat as well. The event code for this is 11881. And finally, I just want to leave my contact information up here so you can contact me at any of these places if you do want to talk a little bit more about specific solutions and things that come up. And let me go ahead and throw all these links in the chat and see what else I've missed now. And I do see a question up here, does Microsoft give some certificates in blockchain? There are no official certificate paths available. We are developing more learning content, so I did throw in the link to the blockchain development course. You can feel free to take that, and you don't get a certificate. You do get some nice trophies at the end that are just kind of fun and show that you did complete that, but there is no official certificate path. And then I did also want to throw in the link to other blockchain videos. And then Emma, actually, would you mind throwing in the link to the survey? And I can actually go back to that too, just so folks have it. Let's see what other questions came in. Why should we go for Ethereum ecosystem over others? I think that's a great question. For much of development that you see around blockchain applications, it has been done on the Ethereum platform. I think, Ethereum was really the first platform past Bitcoin to really explore what else you can do with blockchain technology. So by making it programmable, that has really what's caused people to go and explore development on the Ethereum platform. So I think there's been the most support there and kind of, most advancement. and they have their own programming language that you can use. There are others that you can use as well, so if there's something that you're more familiar with, but it just provides a lot of flexibility about what you can do on the platform. And yeah, there's lots of tools and support around that. And I'll go back to my contact information one more time. Folks, feel free to reach out. I'd like to hear from you. Okay, the JS library that I use for testing. So I'm just using the built-in library, which I believe is Mocha. There is another one. Let me get out of the show for a moment and go over to my browser. So if you look at the Truffles suite, their docs are really helpful. As far as, yeah, we could just look at Truffle. They talk in more detail about testing your contracts and writing tests in either JavaScript or Solidity. So yeah, it is using Mocha as the testing framework and Chai for assertions. So for the most part, what I was just showing was just using what's default and out of the box. There's also something that I use called Truffle assertions, which is a node package. So this is something that you can use specifically to test out things like events and other blockchain specific things and events that are transactions that are happening in your contract. So I think either one of those could be helpful. If you want to go ahead and check that out, and I'm dropping the link in the chat. I can take a couple more questions if we have them, or we can wrap up in a minute. And thank you all. Again, thank you for being here. I hope you learned something new. I think, yeah, again, my call is just like find what interested you and what you want to go explore. Reach out if you want to talk about anything in specific. Join me next week for the AMA where we can get into, I think, some more specific use cases. Anonymous, I didn't forget about your questions, so I think we can go and explore some scenarios around using Geth, I think was the original question. All right, well, thank you all so much. I hope that you all have a great day wherever you are. Take care. Bye.